Good to see you.
Welcome back to another episode of Sasquatch Prospector here. Got a little treat, as per usual on the channel. We're at the Hamilton Steam Technology Museum. As you can see in front of me now, the stack, the old smokestack for what was the wood burning, but then converted to coal, boiler for steam power to power the Hamilton Waterworks, which was started construction of this beautiful Victorian building in 1856. It was completed in 1859, and King Edward VII actually came on his royal tour of Canada and inaugurated the building into action. And it's a waterworks, so it pumps water from one place to another. And the lake that we're on, Lake Ontario, is the water source. So they would pump water from Lake Ontario up into a reservoir on the Niagara Escarpment, but the escarpment runs through Hamilton. So they use the elevation of the escarpment to have a reservoir, which then the head pressure, the gravity pressure of water from the escarpment drop was what provided water to all the houses in Hamilton. So similar to like how a dam generates power, except basically just using the gravity drop from the escarpment to push water through the pipes into people's houses. And this steam museum, or what was pump house, did that job of basically taking the water, pumping it up to the reservoir up on the escarpment so that it could be then pushed down through gravity to supply water. In 1859 is when it was finished being built. And at the time, Hamilton was a big up and coming city. There's a lot of manufacturing, construction, industry, shipping, Stelco and DeFasco, two big steel plants. It's a very industry heavy town. The building on the outside is Victorian style architecture, the Victorian era, with a bit of Romanesque architecture as well. And the inside's got Italian influence as well. So there'll be a lot of really cool things to see, built by British stonemasons, very similar to like what you would see in England. So make sure you check out my videos in England. The museum opens soon. We're gonna go check. You can see I'll get a thing here, Hamilton Waterworks. Dignified building reminiscent of the style of a Roman aqueduct, houses one of the greatest surviving engineering achievements of the mid-19th century, the Hamilton Waterworks. Built between 1857 and 1859, it was designed by the prominent Canadian engineer Thomas C. Kiefer. Welcome to the Powerhouse, everybody. I'm here with Oliver.
Hello.
He's gonna be on the channel today.
Yeah, I'm looking forward to it.
Yeah, man, it'll be a good tour. The building's really cool.
Yeah, I know.
Yeah.
Look at the schematic.
And it's nice and warm and stuff in here too, because it's
Cool
fucking cold.
schematic we got here.
Yeah, yeah.
It's all free. It's all part of the admission. So we're gonna get tours like the whole thing up here.
Yeah, exactly, yeah. This is the escarpment. This is like, because Hamilton's on the escarpment. So they pumped water from the lake through here into the pump house. Well, it's like the water got sucked through here. You can see that wooden pipeline they were talking about over there. They pumped the water through the lake, through all this, up into the waterworks, and then up all the way into this reservoir. And then the force of gravity.
It's a gravity fed.
Yeah, it's a gravity fed system. So then once it was at the top of the reservoir in the escarpment, the drop from it going down from this part down to here basically was what supplied the pressure to power water for like the fountain and all the houses and stuff. So they're basically just using like it's the same as a dam. A dam does the same thing. It takes like the height of water from one place and uses the drop of gravity to like basically, because there's a calculation you can do, because this will tell you like exactly how much pressure will come down through here, and then there's like, it's a whole plumbing thing basically, but like GPM and PSI, and it's similar to kind of power with like voltage and amperage. So voltage could be like seen as pressure. It's kind of an open simplification, but voltage is like the pressure of it, and amperage is the volume, right? Similar to like GPM versus PSI. So, but anyways, but it's just using the height of water. It's called head pressure. The actual proper term for it is called head pressure. And it's literally just like a certain amount of volume of water weighs a certain amount based off the height that it's falling in gravity. And that's how these engineers, these civil engineers, would calculate how to like distribute water throughout everything. And this is a civil engineering landmark.
Building it right now.
Yeah. Well, because this was 1859 that this came out. And to have this sophisticated infrastructure in a small town. There was a bunch of Scottish engineers that they'd worked on Goderich, Petrolia, and here. There was so it's all linked. So Goderich, Petrolia, and this museum were all done by the same engineering guys. They all have the same, like the same. It was a group of them. This was the engineer that designed it.
Yeah, so we're looking sort of side. Oh, cool.
Hamilton was the place to be in this part of the world back then. 1854, they had a cholera outbreak.
That's wild.
It says here, several factors combined to make the waterworks possible. Because they wanted to, and fire departments as well, because everything used to be built out of wood. They built, like in BC, they built a lot of towns out of wood because they didn't have stonemasons out there. And so if there was a fire in one person's house, it would literally like wipe out the whole town.
Yeah.
So like a lot of the ghost towns in BC are ghost towns because they just were destroyed by fire. Like Sandon was like that. Sandon was destroyed like 3 times. So yeah, so it's like, that's the revolutions per minute. That's the water pressure.
Yeah.
That's the vacuum cylinder.
Yeah.
Vacuum and pressure. Cylinder pressure.
And this would have been measured with mercury.
Yeah, and then hang on. Oh, in 1866, more pumping power was needed. So they turned. Oh, the Osborne Killey company. That was the ones they used in Kingston. Those are the
same company.
Different style of engine, slightly different style of engine, but the Osborne Killey Beach pump house until '58. That's the pump right there.
Yeah. Look at the clearance. The stone wall.
I know.
Like how tight everything is.
Yeah. But
They wouldn't have gone fast enough to flex it.
no. But it's literally, you're right. Like you're inside an engine. You're inside an engine.
It's amazing. But instead of driving a crankshaft for wheels, it's driving a pump.
Exactly.
This is crazy. I'm so
That's
happy.
That's a flywheel, man.
Yeah.
It's like it's all the same concepts. They just changed
Look at the size
it.
of the bolts and stuff.
Yeah.
Look at that.
And you can see like, look at the cam. Yeah, it's just like.
I want to touch it so bad. I'm not
I
going
know.
to. But I will.
There's the pump. Like it's so cool. Oh, I'm gonna go there too.
Imagine being a worker on here and like.
Oh yeah, man. Yeah. When you have to pay attention too, right? Because everything's moving.
It
Right?
reminds me of like being on an oil rig or something.
Yeah, oh, yeah. And it'll be loud in here too. So the condenser, like the same in nuclear power, the condenser is what makes it sustainable. Because it just basically takes the steam and then condenses it back into water, which you then use again to make the whole thing function.
Yep.
And you do lose some water, obviously. But
it's pretty good.
But yeah, it's actually sustainable technology. I love how they actually like use the column as like part of the rod. Yeah. Let's see then the
So
next.
that's driven by the
other
crane.
one goes. Yeah,
So
exactly.
you have an exhaust.
It just
technically.
works. Well, it's a double acting steam engine.
Yeah.
There was a guy that invented that. He came up with the compound steam engine.
Compound steam.
Well, the 2 cylinders
Oh right, okay.
instead of 1. It used to be 1 cylinder.
Oh,
But
is that why they have the two cylinders things on the outside of the
Yeah,
front
well,
of
that's
the
how like
cranes?
the one side opens, lets steam in,
Oh.
and then the other side it's double acting. Well, mill rating is so precise, right? Like because they started building wooden mills
Right.
back in the day. It was all the water wheels and stuff, and all that stuff's that's all precise carpentry, right?
Look at
The joinery and everything. So they just transferred it to metal.
Look at the clearances between
Yeah.
these pivot points. Look
Oh,
how
yeah.
close, look at that one. Look
Yeah,
how close
yeah.
that is. That is within like what, a centimeter?
Yeah. Oh yeah. Millimeters probably. Yeah. Cotter pins you use cotter pins on cranes.
Yeah, exactly.
That's how you assemble
Yeah.
cranes is with
That's
cotter
amazing.
pins. Yeah. Very simple
It's
concepts.
super
but
cool.
I love how like the column is actually part of the pump too over there.
Oh yeah.
Yeah.
What are those little cups? Are those oiling cups there?
Oilers, yeah.
Yeah, they are.
Those are oilers. So the oilers would go around and fill these cups with oil. Yeah. And that's how they kept it oiled. So your job would be to be running around checking all these. Like it was a big job.
Yeah. Oh yeah.
And like if you screwed up, it was like you ruined the engine, right? And they had to shut the waterworks down and they'd fix it. But you can see like they just work off each other, right? Like the one side opens and then the other side opens and then the valves are linked.
That's how the cam works.
To the cam, and then the crank.
We have like lobe separation angle.
Yeah, and
you
then-
have,
and-
like you have lift and duration.
And then you
all
have the
that
cam,
stuff.
like so you have the crank is moving the flywheel, like she said, and then the camshaft is timing the valves.
Yep.
It's crazy that what they did back in the day. Everybody was like, oh, they weren't that smart back in the day. I'm like, man, they were probably smarter than
They
we
were
are
the
now.
no, dude.
Like a gas engine isn't efficient because once you burn the petrol, it's gone, or the gas, right? But with steam, you can recondense it.
That's
so you can
really cool.
reuse it again.
I
Right?
didn't
That's
realize
why.
they could reconnect.
That's why. That's the difference, right? That's why.
Ocean liners were able to do
That's the only reason fossil fuels aren't, because you're not combusting here, right? All you're doing is expanding something into gas.
I think
it would be to remove it.
That'd be to remove the top. Yeah, it's a lifting eye.
Oh.
And then the little valve there, that's probably a pressure relief valve.
And
So
then you would crane it up or whatever. Right?
yeah.
Look at the size of the bolts.
Oh yeah, those are all torqued too. Those will all be torqued to like, because of pressure in the gasket. The lady was saying about they'll be in between there. There's like a gasket, right? Same as a head gasket on an engine.
I know how all this works. I know how all this
It's literally just a car engine, but
So
like,
cool.
yeah. Once they found oil and petrolia, that's when they realized they could use combustion fuel. But like I said, the only reason why combustion fuel isn't efficient is because you lose it. You're vaporizing it, right? Oliver, you can see the lobes on the cam here. Yeah, you can actually see the lobe cams. You can see, look at the camshaft, it's all lobed.
Oh, that's a real look at that guy.
Yeah, and look at, yeah, they have the tap, like the tappet and everything on there, like.
Oh, okay, so it would come up and push it.
Yeah, they act on each other, right? The cams spin, right?
Yeah,
like
yeah.
It's like that's the lobed cam, like the cams.
That's interesting. So what they would have had the oil.
Like when you're like on a Hemi, when you have bad valve timing and stuff, and it makes that tick, it's like.
Oh, I know.
Yeah.
I have valve tick right now.
So yeah, these are the little cylinders. These are the big. This is the cam assembly.
Oh, this is the revolutions.
Yep.
Oh, that's super.
And then this is the pressure gauges, right? That's the pressure gauges.
Yep.
That's the brake, I would assume, to like start, like close
that's
everything,
interesting.
right? The flange for the flange, the steam coming.
the
Because this
beautiful
look, the
brass
steam comes in here, right? The high pressure thing, so it probably comes through the floor.
I generally don't.
And then
think
that lever,
steam pumping is cool.
that lever, you could probably there's probably a blind in there that you of like a blank,
What's a blind?
a blank flange.
What's a blank flange?
It's a special thing you use in refineries and factories where it's just like big plate they shove in between
to
two
stop
flanges
stuff?
to stay, just block stuff. It's
Oh,
like
okay.
just like a wall. I don't know if that's exactly what that is. It's hard to tell, but it looks like underneath that's what it would do.
Here, the adults have teaching.
Smokestack. You see the ladder. You can see that ladder that they would have
Did you see this one's less faded? You
And
can see how it's just a rotating.
So this is the actual walking beam, right? Walking beam engine pivots on a fixed point, right? So right here, yeah, exactly. Camshaft, water pump, flywheel, crank. Yep. Waterworks,
rather, yeah,
water
waterworks.
tanks, waterworks down there, and then pistons over there. And this is Italian influenced architecture, all the balustrades and stuff. This is all Italian.
Italian.
Well, no, it's Roman. So that building out there,
Catholic
that's Roman influence. This building is Victorian, and then the inside of this building is Italian. So it's like it's three different architectural styles. So it's like because these columns and stuff, it's all like very Italian style, and then the outside is Victorian style.
Italians were the builders, or
Yeah,
the refined builders.
Yes, exactly. So that's why it feels very like it has a regal feel. It's all brass and fine wood and carving and look like these columns and like how they've incorporated the column is actually a part of the rod that moves the pump. Like the pump piston, the piston that actually actuates the pump is literally a column that moves. But you can see it's the same thing here: camshaft, crank, pump, pistons, and then you have the lobe assembly, like the cam lobe, like the valve timing over there. It only took them like 3 years.
That's
Well,
amazing.
it's conflicting. It says 1857. I've heard 1856, but probably 1857. I'd imagine. I don't think.
So 2 to
I
3
think the
years.
idea came up in 56, and then by 57 they got the funding and stuff, right?
There was so much happening.
There was a lot of bidding.
1842 and
Like,
1860.
there was a lot of bidding because they had to bid for the job and stuff, right? The contractors to prove like they could do it, and then
It's the same world.
and that,
Just 106 years
engineer,
ago.
that engineer Kiefer, he was the one that said this was his baby. But yeah, this is the cam assembly, Oliver. And you can just literally see the lobes, right? And then each one, the timing bit, like will hit those tabs.
Yeah.
And then that was what times the cam.
That's right.
Which then times all the valves. What's that?
This little plate right there. What is that? Like, why does it move? Why does it move like that?
Oh, it's the double acting. That's the double acting. So if you put a steam in one side, steam in the other side.
Oh, okay.
That's what because it's opening and closing that, right? That's really cool. That one was at the Tower Bridge.
Yeah, that's the tower bridge.
Yeah, and that's the
That's over.
yeah, and it pivots on the central plane.
Yep. Yes, exactly.
And it's same. See the timing?
So
it's all
piston's
lit.
pushed up by the pressure.
Yeah.
That pushes it down. That drives the crank. That drives the flywheel. And you can put things on here to drive other
Exactly. Yeah. So that's gonna be it, guys. If you're ever in Southern Ontario and you find yourself in the Oakville, Toronto, Burlington, Hamilton area. It's pretty close, 45-minute drive from the airport. And yeah, there's a steam museum. Definitely come check it out. Sasquatch out.